Recording. All right, so welcome to today's lecture. This is lecture 3, and we're looking at types of numbers. And then apart from that, we'll look at rational numbers in details. All right, so types of numbers. The first type of number that we're going to discuss are what are called even numbers. So I'm sure you know what even numbers are. I'm just going to run through the types of numbers because most of them, I believe, you know them. So types of numbers, the first one we'll look at is even. So when we talk about even numbers, these are just numbers where 2 can go in without leaving a remainder. Or you can define even numbers as numbers which are divisible by 2. Yes, so numbers that are divisible by 2, they are all called even numbers. Then we also have another set which is called the set of odd numbers. So odd numbers, these are numbers where if you divide 2 into such a number, you always have the remainder 1. Every time you divide 2 into an odd number, there's always a remainder 1. Okay, so also have what are called complex numbers. So complex numbers, we're going to discuss them in details. I know there's a topic that is coming called complex numbers, but for now, let me just mention to you that complex numbers are just numbers, numbers that consist or that contain an imaginary number, or is in other words, they are called imaginary numbers. Let me say so. So complex numbers are also known as imaginary numbers. And then when we talk about a complex number, we're talking about numbers with this type of format. Okay, let me just write the format of a complex number. So the format of a complex number is A plus BI. So A plus BI, and they are usually denoted by Z. So this part here is called the real part of a complex number. Then this one, we're going to learn this. I'm just introducing them. This one is called the imaginary part of the complex number. So this one is the imaginary part, this one is the real part. And then this I you are seeing here, I is simply just equal to the square root of -1. So I'm sure you've come across numbers where maybe you've been asked to find the square root of -25. So the square root of -25, if you have not yet done complex numbers, you always say it does not exist. You always say the square root of a negative number does not exist or undefined. But
I can't get you.
You're not getting me? Hello? You're not getting
No.
me?
No, I'm not.
But how come?
It's skipping.
Oh, maybe where you are, the network. Okay, let's continue. If it continues like this, I'll just record the session and then send it to the group. All right, so when I talk about, I'm sure now you're able to get me, right? Okay, so I was saying if you've been asked to find the square root of -25.
Yes.
Yeah, so the square root of -25 is simply just, according to just normal numbers, we say it doesn't exist. And when you talk about complex numbers, the square root of -25 is just the same as the square root of -1 times the square root of 25. Oh, let me do this. So this is just the same as the square root of -1 times the square root, times 25. And then we can separate this and say this is square root of -1 and then times square root of 25. So the square root of 25 is 5, and then square root of -1 is this one here, which I said is negative, it's simply just I. So square root of -1 is I, and then the square root of 25 is 5. So when you multiply the two, you get 5i. So this same applies to a situation where you've been asked to find the square root of -9. So in this case, it's just going to be 3i. Square root of -49 The answer will be 7i. So that is exactly what we call complex numbers. All right, let's look at another set of numbers. So we're going to discuss complex numbers in details as time goes on. Okay. So we also have what are called prime numbers. So prime numbers are simply just numbers with only two factors. Yeah, so numbers that that only have two factors, they are called prime numbers. So numbers like 2, 3, 5, 7. So these numbers are prime numbers because 2 only has two factors, 1 and 2. 3 only has two factors, 1 and 3. 5 only has two factors, 1 and 5. 7 only has two factors, 1 and 7. So these numbers are called prime numbers. Okay, let's talk about also natural numbers. So natural numbers are simply just counting numbers starting with 1. So counting numbers starting with 1 are called natural numbers. So counting numbers starting with 1, when you're counting numbers and then you start with 1, those numbers are called natural numbers. Usually these are sometimes called positive integers. Then we have what are called whole numbers. So whole numbers, this is just a set of natural numbers. When you add a 0 to a set of natural numbers, then you come up with a set that is known as the set of whole numbers. So the difference between natural numbers and whole numbers is that natural numbers do not have 0, do not start from 0, and then whole numbers start from 0. Yeah, and then we have another set of numbers that is called the set of integers. So integers are simply just positive and negative whole numbers, in short. Yeah, positive and negative whole numbers, that's all. We also have what are known as rational numbers. So these are just numbers that can be expressed in the form A over B, where A and B are members of integers. So the letter Z is there to denote integers. So any number that can be expressed in the form A over B, where A and B are members of integers, and then B is not equal to 0, then A and B are always in their lowest term. So we say A and B are co-prime factors. So we say A and B are co-prime factors because they are in their lowest term. So this is how we define a rational number. So this is a rational number. So this is where we're going to dwell today. This is what we're going to discuss today. All right. So real numbers. When you talk about real numbers are simply just a set of rational numbers when added to a set of irrational numbers. So when you combine rational numbers and irrational numbers, you come up with a set that is known as the set of real numbers. So when you add rational numbers and irrational numbers, you come up with a set called the set of real numbers, and it's denoted by the capital letter R. So that is what we call real numbers. So real numbers, when you combine rational numbers and irrational numbers, you come up with what are called real numbers. Yeah, so it's also important to know what an irrational number is. So we said a rational number is a number that can be expressed in the form A over B. An irrational number, it is impossible for you to express an irrational number in this format. So the opposite of rational number is what we call irrational numbers. So if you can express the irrational number in the form A over B, an irrational number cannot be expressed in this form, which is A over B. This can't be expressed, the irrational number can be expressed in this form. So these types of numbers are numbers like the square root of 2, square root of 3, square root of 5. You can't express square root of 2 and square root of 3 in the form A over B. So these these numbers are called irrational numbers. So when you add this set of irrational numbers to the set of rational numbers, the answer that you get, or the resulting set, will be a set of irrational numbers. Okay, so let's take a look at some examples. We have this example here. So this example, if we're to determine which one is a rational number and which one is an irrational, discover that this one is a rational number, this one is also a rational number, but this one is an irrational number. So pi is an irrational number. There's no way we can express pi in the form or in the form a over b. So pi is also an irrational number. So let's quickly move on. Okay, so some of the real numbers, they have what's this? They have decimal parts which repeat. So like this one here, we have 2.12121 is repeating there. So you can just represent this by in this format. You just say 2.12 bar. So where you put a bar there, that shows that 1 and 2 are repeating. That's why it's like that. And then it also applies to a situation where you have one number repeating, like 5 is repeating in this case. So you just put a bar on top of 5. Then you've shown that 5 is repeating. All right. So let's now look at the rational numbers in details. So we said rational number is a real number such that when expressed in a decimal form, its decimal part either terminates or repeats. So we have repeating rational numbers. So repeating rational numbers are numbers that are repeat, like the examples that I'm just from giving you. And then we also have terminating rational numbers. So terminating rational numbers are just the normal fractions that we know. For instance, 1/2 or 4/5 or 5/4. These are numbers that can easily terminate. So you are going to have something like, if you have 1/2, 1/2 is when you divide 2 into 1, you get 0. 2 into 10, you get 5. So you have 0.5. So 0.5 is terminated. There is nothing repeating this side. So this one is called a terminating rational number. But there is also what are called repeating rational numbers. So repeating rational numbers have always a number that is repeating. They always have a number that is repeating. These are called repeating rational numbers. All right. So let's take a look at some of the repeating rational numbers, and then we call it a day. I wanted us to do 2 slides tonight, but seeing that a lot of people have not joined, we might leave them very fast. So I'll just do this slide, and then tomorrow, if we're going to have time after physics, then we can do another slide for mathematics. So we'll do just this slide. I wanted us to do lecture 3 and lecture 4 today, so that next time when we meet, we just come and start functions. Now, a lot of people are not about them, they have not joined us. So we'll just do this slide, and then next time when we meet for physics, I'll do physics first so that we can do the other slide. Okay, so we have this question here. In the following problems, find the form A/B of the given decimal expansions. So in other words, they are trying to tell you to say, express 3.2 bar in the form A/B. So they are telling you to say, express this as a fraction. So the first step when you're expressing that as a fraction, you say let x be equal to 3.2 bar. That's what you have to do. So after doing that, now you have to move this point closer to the repeating number. In this case, 2 is repeating. And since the point is already closer to the repeating number, which is 2, so we have to skip that step. So the first step, step 1, move this point, move the decimal close to the repeating number, close to the repeating number. And then step 2, we now have to move this point to cover the number that is repeating. If you have 3 numbers that are repeating, you move the point 3 times. If you have, in this case, we have 1 number. So this decimal point, we just move once to just come there. So when it moves once this side, you also add a 0 to the coefficient of 1 this side. So this is just the same as multiplying by 10 on both sides. So when you multiply, when you move one step, it's just the same as multiplying by 10. When you move 2 steps, it's just the same as multiplying by 100. When you move 3 steps, it's just the same as multiplying by 1000. So in this case, we're moving 1 step. So this is just the same as multiplying by 10. Hence, this part, we're going to multiply 10 times x, we're getting 10x. And then on this other side, we multiply 3.2 bar times 10, we're going to get 32, but this 2 will still repeat because it's a repeating number. It's like we have 3.2222, the 2's are just repeating. So even if we multiply by 10, you still have 1, 2, which is repeating this side. So after doing this, we now have to subtract what you have found minus the equation there on top. So we subtract, so we're going to say 10x minus x, 10x minus x is equal to 32.2 bar minus 3.2 bar. So I'm going to say 32.2 bar minus 3.2 bar. So 10x minus x, the answer is 9x. Then this other side, 32.2 bar minus 3.2 bar, the answer is simply just 29. So when you divide 9 this side, even 9 this side, the answer that you get to simply just be 29 over 9. So if that is a way that you can reduce that number, you can simply just do the reduction first. You find the number that can go into 9 and 21 and 29 and reduce it. But in this case, we don't have any number that can go into 29 and 9. So we leave it here. Therefore, x is equal to 29 over 9. So we have expressed this expression in a fraction form. So this sometimes this question they will ask you to say, prove that 3.2 bar is a rational number. Remember the definition of a rational number. We said every rational number can be expressed in the form a over b. So for you to prove that this is a rational number, you have to express it in this form, which is a over b. And in this case, we have proved, we have expressed it in the fraction form. So let us move on to the next one. So the next one is 3.12. So the next one is 3.12. First step, you say let x be equal to 3.12 bar. So we are going to, so 3.12 bar. So what we'll do here is that we're going to move this point to cover the repeating decimal places. So we are going to multiply by 100 since we're moving 2 times. So 100 times x, we're getting 100x. And then this is equal to 3.12 bar times 100, we're getting 312.12 bar. So here now we have to subtract 100 minus x, 100x minus x, then is equal to 312.12 bar minus 3.12 bar. So 100 minus x, the answer is 99x. Then on this other side, 3.12 bar, let me write it here. We have 312.12 bar minus 3.12 bar. So if you do the subtraction there, this minus that, you get a 0 there. Then 2 minus 3, the answer is, we get a 1 from this one there. So get 12 minus 3, the answer is 9 there. Then you get a 0 there. 0 minus 0 there is 0. 3 minus 0 is 3. So the answer is 309 there. So I have 309, and then we divide by 99 there. And then the value of x will therefore be equal to, you reduce this 309. You can reduce 309 by dividing everything. The numerator and the denominator can be divided by 2. So when you divide 309 by, can be divided by 3 rather. When you divide 309 by 3, 3 into 3, the answer is 1. And then 0, 3 into 9, you have 3. 3 into 9, 3, sorry. And then 3 into another 9 is 3. So the value of x is therefore equal to 103 over 33. So you can conclude by saying 3.12 bar is equal to 103 over 33. So this is exactly how you solve even C. So let us move on to C. So C, we also do the same. Let 3.34 bar be equal to X. Or let me do it the way I've been writing it. So we say let X be equal to 3.34 bar. So this point will move 2 times. When this side, it means that we're going to multiply by 100. 100 times X, you're getting 100. X is equal to 3.34 bar times 100. This will be 334.34 bar. So we'll do the subtraction. 100x minus x. So I have 100x minus x is equal to 334.34 bar minus 3.34 bar. So 100 minus x, we get 99x is equal to, we have 334 minus 3. So we have 334.34 minus 3.34. Okay, we have, let me just write it, we do it together. 334.34 bar minus 3.34 bar. So this and that will give us a 0. 3 minus 4, that's a 1. So you have 331 over 99 this side. So the value of x is therefore equal to 331 over 99. So can we reduce this? It's not possible. So if we can't reduce it, then we just say 3.34 bar is equal to 331 over 99. Yeah, so that is exactly what you are supposed to do when you've been asked to express the repeating numbers into fraction forms. So I don't know, do you have any questions? Do you have questions? Do you have questions? All right, so if you don't have,
I don't have questions.
All right, so if you don't have questions, then let's meet tomorrow for physics. If you are also in the physics group, then we'll meet for physics tomorrow, and then immediately after physics, we'll proceed with lecture 4 for mathematics. It's also a short lecture. I wanted us to do irrational numbers, but since there are a lot of people are not around, irrational numbers proving, let's say for instance, the root of 5, prove that the root of 2 is an irrational number, prove that 1 plus the root of 2 is an irrational number. This is what I wanted us to do in the next lecture. But since a lot of people are not available today, we might do something, and then the same questions, I mean the same things again maybe becomes a maybe it's a stumbling block to a lot of people, because I know that a lot of people find challenges to prove this. That's why I wanted everyone to be there. So we'll just do it together maybe tomorrow. If tomorrow will not manage, then the next time we're going to do mathematics, I'll go on this. Then after this, we'll also do binary operations and radicals in the same lecture. All right. So thank you very much.
Right.
See you tomorrow for physics.
Okay.